Okay. So it's nothing, she says. Okay, so let's talk about this. This is, I think, a really important picture. Remember, what are we talking about here? What are we doing? What enzyme is this? Okay, and what is its overall purpose? Okay, so to generate tons of ATP, right? And you would only do that if you had plenty of ADP and inorganic phosphate. Now, we've made ATP a couple times before in this stuff, right? Where was one time that we made ATP? Okay, that was one position. Remember, we made ATP. Two of them in glycolysis. And remember, we made ATP. Two of them in the Krebs cycle. What type of phosphorylation is this? Is this... What type is it?
Substrate level.
Very good. Substrate level. Gotta know that. So I would say that now we have not substrate level phosphorylation, but I would say that this is oxidative. Not me. Oxidative phosphorylation. Okay, cool.
Wait, I have a question.
Mm-hmm.
Were you going to explain like what each one is? Substrate level and
Phosphorylation.
phosphorylation.
Well, I mean, there's really not much to explain. Substrate level phosphorylation occurs in glycolysis and Krebs.
But what does like substrate level mean?
It means that you are directly taking the phosphate off of the organic molecule and putting it onto the ADP. Because so the phosphate that was utilized to make the ATPs here was found on the glucose derivative. Whereas in this case, your phosphates are just randomly free floating. And the term oxidative, that would to me that would make reference to oxidation, right? Yes. Okay. Well, first off, we should remember, and I'll get back to that oxidation in just a second. You have a lot of H pluses on this outside area. If I was to label this, I think I would label this as being the inner membrane space. And I would label this as being the inside of the mitochondria, so the mitochondrial matrix. Right? And remember that H pluses are going to go which direction? Down, straight through to the inside area. What's the name of this enzyme? Okay, ATP synthase. And what type of gradient do we have up here? Do what?
Like down the gradient?
Yeah, you're going down the gradient. What would be the name of this type of gradient? There, it's like a 2-for-1 gradient. It's a chemical gradient because of the H's, right? And because of the unequal distribution of the positive charge, it's electrical. So this is an electrochemical gradient. You could also call it a proton gradient. Either which one is sufficient. Cool.
So one egg replace the other.
Go ahead.
So one egg to replace the other.
Yeah, they're interchangeable. So zooming into this, or zooming out, I should say, I'm sorry. If that's your mitochondria right up top, I would say that we are really focusing on a system that's kind of right through here. This system would be right in that area. Cool? We A-okay. We all read chapter 9, right? Question.
How big is the HB synthase to like the...
Not very big. Not very big at all. Enough times that this is replicated many, many, many times on the infolded, now you know why it's infolded, inner membrane. A lot of times. And you have thousands of ATP per cell, so you can see where this is going. Tons and tons and tons of energy.
So when like you're going through this cycle and like it has to do it twice because there's like 2 pyruvates.
That was because that was in Krebs cycle.
Okay, so like at this point it's all.
At this point, there's no more C at all. You burned off all your C. So all we're talking about is all these H's that are in here. And now I need to talk about exactly where are those H's coming from. Yeah, I mean, you know where they're kind of coming from. But I need to really talk about like very specifically where are they coming from. Remember that you pulled off all those H's along the way, right? You bankrolled them into what molecule? NADH, right? And so I think what we would want to talk about here is how are we able to get our NADH broken up into my H pluses, right? Okay. This right here, actually let me go back. I would, if I was to call this picture something, I could say it's ATP synthase, and that's fine, but I like this title better. Chemiosmosis. What does osmosis mean? To move. Chemi, moving of chemicals. Okay. Let's look at this drawing. If I was to give this drawing a title, what would I title it, do you suspect? I would say electron transport chain. So that's what I'll do. I'll title this the electron transport chain. Now when we think about that term, the electron transport chain, this would have to be a chain of events, but you could kind of guess this happening, that's transporting electrons. So electrons have got to be moving. Now as a review piece,